Welcome. In this video, we are going to use the law of cosines to solve this triangle. So let's read the problem first. We have a group of students who's learning to navigate. On a map, they've been given three locations, U, S, and T, and they need to check in at those locations. Well, in order to navigate, they need to know the angle measurements that they need to travel. They need to find these angle measurements. So we're going to solve this triangle and find those three missing angles. We're given three sides, which means this is a side, side, side triangle, and side, side, side means we're going to use the law of cosines. So I'm going to take a minute and go ahead and label my sides. Remember, we label angles with capital letters, and then the sides opposite each angle, pointed wrong there, but the sides are going to be labeled with the lowercase letters. So at the bottom, that would be little s. Over here on the left, we'll have little u, and on the right, we have little t. All right, so we've got a t value, an s value, and a u value here. All right, so we need to find an angle, and we can start with either one. We're going to need to use the law of cosines twice. Once we found two angles, then of course we can subtract those two angles from 180 to find the third angle. So let's think of a setup, right? Let's think about how we would set this up. Remember I talked about memorizing this law of cosines not as a formula, but as a pattern. So in this situation, we're dealing with triangle STU, or however you want to call it. So suppose we want to find angle S. Well, then I would start with S squared, and I know I would have cosine of S over on the right. Now I'm going to finish writing the rest before I have my cosine S. So since I'm using S squared on the left, that means I have T squared plus U squared minus 2T times U. And then that would be times the cosine of S. So I want you to go compare this with your previous notes and make sure this makes sense how I've set this up. Remember, I said that when we're solving, the biggest issue I see is students plug all of these numbers in and then they calculate incorrectly. Let's look at what this would be if we plugged all of our numbers in. So side S, we have 45.2, that's going to be squared. T, 22.4 squared, U, 31.6 squared, minus 2 times 22.4 times 31.6 times the cosine of angle S, which we do not know. So here is the big problem that I see students run into, is students want to go ahead and just calculate this whole number and divide by it. And we can't do that because that would be breaking order of operations. So what I want you to make sure you notice is that this is added, and then this next piece right here, the -2, that is multiplied. So in order for us to isolate S, we would first subtract these two values. And what that gives me is 45.2 squared minus 22.4 squared minus 31.6 squared equals -2 times 22.4 times 31.6 and then times cosine of big S. Now, at this point, we would divide. So I have 45.2 squared minus 22.4 squared minus 31.6 squared. All of that is divided by this coefficient, this number that we have in front of cosine S. So now we have -2 times 22.4 times 31.6. That's equal to cosine of capital S. Now, in the effort to isolate S, we're going to use the inverse operation to move cosine to the other side. So we have cosine inverse of the quantity, my argument here, is 45.2 squared minus 22.4 squared minus 31.6 squared, all divided by negative 2 times 22.4 times 31.6. And this, of course, equals capital S, my angle measure for S. So I just want to encourage you, when we type this into our calculator, we're going to use parentheses 45.2 squared minus 22.4 squared minus 31.6 squared. Parentheses around the entire numerator. Put your divide by slash, then you need parentheses around the entire denominator. So negative 2 times 22.4, and instead of, you can use a times instead of parentheses here, so you'll get a little star on your calculator, 22.4, and then times 31.6. Now we still need to take cosine inverse of this, but the value we get here from our calculator, just that argument, is negative 0.383363,472. And the reason I write all of these decimals is because I want to make sure when you type it in the calculator, you get the exact same thing. So at this point, I would type cosine inverse, again, making sure that you are in degree mode, but cosine inverse of, and I would use the answer button. So if you hit second negative, that's going to pull up your answer. And that's plugging this value in. And what that gives me is that my S value is equal to 112.5421801, or we could just say 112.5 degrees. All right, now we also talked about pushing the store button. So while this number is on your calculator screen, go push the button that says STO with a little arrow on it, this button. And what that's going to bring up is it's going to say answer with an arrow. And you can choose to type, you'll type alpha, that's going to bring up your letters, so alpha, and then pick the letter S. And that way we can call this S, and we can store that in case we needed to use S again. All right, now S is an angle measure. We're only going to really need that when we do our subtraction, but that could be helpful for you. Okay, so let's go back up. Now that we know that angle S is 112.5 degrees, let's find a different angle, maybe angle T. Now my formula set up using the law of cosines for angle T is going to be T squared equals S squared plus U squared minus 2 SU times the cosine of big T. And I know we've looked at a problem before where I went ahead and rearranged this. So we could say that T is the same as cosine inverse of T squared minus S squared minus U squared all over negative 2 times S times U. So that's the same formula, it's just solved for T. All right, so I sometimes find, recognizing this pattern and you do enough of these problems that you just kind of know this is the way you're going to set it up to find that value. So from here, I'm going to plug my T and my U and S values in. That's going to be cosine inverse of 22.4 squared minus 45.2 squared minus 31.6 squared, all divided by negative 2 times 45.2 times 31.6. So performing these calculations in our calculator, simplifying what we have in parentheses for our argument, we get 0.8891004817. And when we take inverse cosine of that, in degree mode, we get 27.23956943. And of course, then we round that 27.2 degrees. So, give myself a little space. We've got angle T is 27.2 degrees. That means 180 degrees minus S and minus T. That's going to give me U. Subtracting both of those, I get that angle U is equal to 40.2 degrees. You may say, well, Miss Stein, we have 3 angle measures here, and these do not add up to equal 180. Well, that's because I didn't literally subtract these approximated values. I subtracted my exact values, and subtracting my exact values, my number rounds to, or the exact number I get in my calculator, approximate number, I get 40.21825046. So this was the number I got in my calculator, which rounds to 2. If I had subtracted these 2 approximations, which are rounded from 180, I would end up with a 3 here. So again, that's just to re-emphasize, try and use those exact values, store the numbers, or use the answer button to help you, or at least keep more than just one decimal place. So that concludes this video on using the law of cosines to solve a side-side-side triangle. Good luck, and email me if you have any questions, comments, concerns, whatnot. Good luck out there.